Welcome to the demonstration video of a hardware Trojan for functionality changing. I'm going to demonstrate that, but before that, let me explain the switches to verify the normal operation of RC5. The first one is the clear, which is the active low clear. The next two switches are the data valid and the key valid switches. The next four switches is used to select the byte which we want to give as input. And the next 8 switches are the ones which is used to give input to the encryption module, the decryption module, or the key module, round key generation module. So right now everything is at 0. So I will be encrypting or decrypting all zeros. So these two push buttons here manage what data we want to see on the LEDs, and if we want to encrypt or decrypt the data. So the Trojan which we have designed is triggered by a counter, and when the counter reaches a value of 1 billion, which is approximately 10 seconds, the first bit of the user key is flipped. So if it's 0, it becomes 1, and here we get a garbage value. So when we start the encryption module, we can see that this is encrypting the data, which is valid because it is there in the Ron Rivers original paper. But after 10 seconds, it changes the value, and it remains so. So if we want to again reset the system, we need to reset it, and then I will again get a proper value, but then again after 10 seconds it will change the data because the first bit of the key will be different from what the user has input. Again, it has changed. So this is the hardware Trojan for functionality changing. Thank you.
This is a demonstration of a key-leaking Trojan. This Trojan is implemented in VHDL with some basic blocks like LUTs and flip-flops, and some macros like counters. The trigger for this Trojan is time. It's timed to start after a certain interval, in this case after about 1 second, and it leaks the cryptographic key of the RC5 algorithm. The key that it leaks is 5, that is 101, and it currently leaks just the 4 leftmost bits, rightmost bits of the key. That is the 4 least significant bits. This is done through the decimal point part of the 7-segment display, which is it alternates between 0 and 1 to leak the cryptographic key. It is off when the key bit is 0, and it's on when the key bit is 1. With this demonstration, now we can see the decimal points are continuously on, but if we slow down the video, we can see the bits actually alternating between 1 and 0, which is the key 1, 0, 1, or 0, 1, 0, 1. So what follows is a slowdown of this video in order to see the actual key leaking of the cryptographic key.